Hello everyone, welcome to this session on Numpy Basic operation. In this session we are going to discuss about array join, split, search and sort operation. Let us begin. First we are going to see about array join. In Numpy, array join it means combining two or more array into a single array. We have three common functions in Numpy: np.concatenate of, np.vstack of, np.hstack of. np.concatenate of, what it will do, it combine array along an existing axis. np.vstack of, it perform vertical join, that is joining array row by row, one below the other. np.hstack of, it perform horizontal join, that is join array side by side, that is column wise. We can understand this in detailed manner by using the following example. First we are going to see about concatenation. To perform concatenation, initially I am creating two separate single dimensional array by using the function np.arrayof and store it in AB. Then I am performing concatenation by using the function np.concatenate of a comma b. See the output here. What this function will do, it will joining these two array along an existing axis. Next we are going to see about vertical join. So to perform vertical join, initially I am creating two separate single dimensional array by using the function np.arrayof, store it in A and B. To perform vertical join, we will be using the function np.vstack of a comma b. So what this function will do, it joining array row wise, that is A array will be the first row and B array will be the second row. So it will be joining the array one below the other. To perform this, we need same number of columns required for both the input array. Next, we are going to see about horizontal join. To perform horizontal join, initially I am creating two separate two-dimensional array by using the function np.arrayof, store it in A and B. To perform horizontal join, we will be using the function np.hstack of a comma b. So what this function will do, it will joining array column wise, that is side by side. See the output here. So the first row of A array and the first row of B array will be joined together, and the second row of A array and the second row of B array will be joined together, that is side by side. To perform this, we need same number of rows required in both the input array. Next, we are going to see about another two functions, stack and depth stack. First, we are going to see about stack. So stack, what this operation will do. So this function, what it will do, it will add one new dimension in an output array. So first we can see the stack. So to perform stack, initially I am creating two separate two-dimensional array using the function np.arrayof. So A array and B array. So after creating the array, now I am printing the shape of A array. See the output here 2, 2. That is 2 rows and 2 columns. If suppose I am printing the shape of B array, it will be also return the same result 2, 2, because these array also having 2 rows and 2 columns. Now I am performing stack operation by using the function np.stack of a comma b. Then the resultant will be stored in S. If I print S, see the output here, it will be adding one new dimension in the output. See the input will be the two-dimensional array. But see the output will be the three-dimensional array. So this is first block, this is second block. So after doing this, if I am printing the shape of this resultant array, see the output here, two blocks of 2 rows, 2 columns. So this was the example for stack. Next we are going to see about depth stack. So depth stack, which means it combine array along depth. We can understand this by using the following snippet. To perform depth stack, initially I am creating two separate two-dimensional array by using the function np.arrayof, store it in A array and B array. To perform depth stack, I am using the function np.dstack of a comma b. So what this function will do, it will combine array along depth. See the output here. So it will combine along depth wise, it will be combining. So this first row of this A array and the first row of this B array will be the first block of output array, and the second row of this array and the second row of B array will be the next block of the output array. But see here, this first row will be as here the column, and this first row of B array will be the column, and this will be the first block. And see the second block, this second row will be the first column and this 7 8 of B second row will be the second column. So it will combine array along depth. Next, we can see the comparison and general rule for numpy join. So these are the joining functions so far we have discussed. So if it is a v stack of, here we will be using the axis 0, direction will be top to bottom, result will be it increase rows. If it is a h stack of function, axis will be 1, direction will be left to right, result will be increased column. If it is a concatenate of operation, axis will be user defined, direction will be along given axis, resultant array will be in same dimension. If it is a stack of operation, axis will be new axis, direction will be layer wise, resultant will be it increases one more dimension. If it is a D stack of, axis will be 2, direction will be front to back depth wise, resultant array will be, it is depth wise increases and it is also increases one more dimension. Okay, for a 2D array, if the axis is 0, general operation will be rows are collapsed, that is column wise result we will be getting. If it is a join operation, rows are added, that is it increases rows. If it is axis equal to 1, in general operation columns are collapsed, that is row wise result we will be getting. But in join operation columns are added, that is it increases column. The same way, for a three-dimensional array, generally if it is a three-dimensional array, the array shape will be like this: rows, columns and depth. So for a three-dimensional array, generally axis is 0 means it represents rows. Axis will be 1 means it represents column. Axis is 2 means it represents depth. But in join operation, axis is 0, which means it increases rows. Axis is 1 means it increases column. Axis equal to 2 means it increases depth. Next we are going to see about array split. In NumPy, array split, which means dividing one array into multiple smaller array. So in NumPy we have two common function, np.splitoff, np.array underscore splitoff. np.splitoff, which means it handle equal split. np.array underscore splitoff, which means it handle unequal split. We can understand this by using the following example. First we are going to see about equal split. So initially we are going to see the example for a single dimensional array. So first we can see for equal split. Initially I am creating array by using the function np.array of. It's a single dimensional array. So I am creating the array initially with 6 elements. Now I am going to do the split operation np.split of a comma 3, which means so the given array will be splitted as 3 array if it is a equal split. So see the output here. So it will be given as 3 separate array, each having 2 elements. If it is an unequal split, see the code here. I am creating array by using the function np.array of. Initially I am creating the single list with 11 elements. I am creating the array and store it in the variable arr. I need to perform unequal split. If I want to perform unequal split, this was the function np.array underscore split of arr comma 3. See the output here. If it is an unequal split, initially the single array will be having 11 elements. See the output here. I need to split this 11 elements as 3 separate array. So if it is an unequal split, so I am getting 4 elements, 4 elements for the first 2 array, and the remaining array will have 3 elements. So this was the example for equal split and unequal split for single dimensional array. If it is a two-dimensional array, see this code to understand it better. So if it is a two-dimensional array, see I am performing first equal split. If it is a equal split, I am creating two-dimensional array by using the function np.array of. So here I am creating 3 rows and 3 columns. It's a two-dimensional array. It's a list of list, right? So if I want to perform equal split, this was the function np.split of array name comma 3. So here I am performing, I need to perform this single two-dimensional as 3 separate array. So since it is a equal split, so this single two-dimensional array will be converted as 3 single dimensional array. So first row will be one array, second row will be another array, third row will be another array. So this is the equal split. If suppose, so the same thing will be used for unequal split. So this was the function to perform unequal split, np.array underscore split of arr comma 2. So since it is an unequal split, so this given 3 cross 3 single two-dimensional array will be converted as two separate array. See, the first array will be have two rows, and one more array will have one row. Like this, it will be performing unequal split. Next, we can see array search. Array search, which means finding the index position of a value in an array. So to perform this, we will be using the function np.varof. So see the example code. Initially, I am creating array by using the function np.arrayof and store it in a variable a. Now I need to find the index position for a value 10 by using the function np.varof. So np.varof a equal to 10. So by using this function, I need to perform the index position of 10. See the input here. In input, 10 will be present in two places. So it will be returning the index position of the 10. So it will be return the two index position of the 10. So 10 will be present in first position as well as third position. Next, we are going to see about array sort. Array sort, which means arranging element in an ascending order or descending order. To do this, generally we will be using the function np.sortof. So see the example code here. I am creating one array by using the function np.arrayof. So if I want to perform ascending order, I am using the function np.sortof. So what it will do? It will be sort this array in ascending order. So if I want to perform descending order, this was the function np.sortof followed by, within a square bracket, I have to give double colon minus 1. If I am doing this, what it will do? It will be printing the array in a descending order. So far we have discussed Numpy basic operation. Remaining things we will be discussing next session. Thank you for watching.